comparing slide decks and that type of thing. So hopefully our decks integrate pretty well with one another. A little bit of an introduction. Brad and I are just two bad men from Chattanooga. That actually, it's not completely just a movie reference. Russell, you can't answer this question. Do you know which one of these two men actually is from Chattanooga? Who can take a guess?
Samuel Jackson.
Samuel Jackson, that's right.
Blue team!
That's right. And I tried to connect it a little bit there, but I think Brad's more of the longer hair guy here. But anyway, a little bit by the way of introduction. Brad, you want to go ahead and introduce yourself?
Yeah, sure. I've been in IT since mid-90s and security focused for the last 6-7 years. I'm an active documentation, testing, and marketing contributor to Security Onion, which you've hopefully just heard about. I was involved in helping technically edit Richard Bailey's new book, The Practice of NSM, which really is a must-read if you're interested in network security monitoring. I put together the Security Onion for Splunk apps a couple of years ago, and I haven't updated in a while, but they're still quite functional. And currently, I work for Mandiant.
My resume is not nearly as interesting. I will say this, and then get it Brad here. I have spent probably half as much time in IT and half as much time in IT security as Brad has. And I have, I think, 1/4 as much gray hair in my beard. But Brad, this is brand new for Brad, so that's why we got it on there. It looks great, by the way, man. Fantastic. Anyway, just a little bit about former IT director, former security consultant. I actually was red team for a while before I joined Mandiant. It was blue team. So I've actually converted.
Blue team!
That's right. Personally, I have 3 boys at the house, 4 and under. My middle one actually turns 2 today. My youngest one is less than a month old. So you can add to that resume expert diaper changer, expert moderator. And so this is actually my first time I've left the house since my youngest was born. So actually my wife really deserves all the credit on that one. She's the one who put the most work into this presentation, is going to pay for it. Anyway, now with Mandiant, and I am a ISSA board member in Chattanooga as we try to get that rolling. And these type of conferences I'm inspired by, so hopefully we can do something like this one day in Chattanooga. Anyway, what's the agenda for today? We're going to talk about, we're going to start with buzzwords, we're going to go with big data, and then we're going to start in Security Onion. We're going to talk about why that's important and some of the information there. We're going to take a look a little bit at Splunk versus ELSA. It seems to be a common thing that comes up, especially when you're dealing with Security Onion. Brad is going to talk about his Splunk app a little bit. We're going to take a look at ELSA and hopefully prime you for Martin's talk coming up. We're going to look a little bit at the architecture overview. And I think, you know, even though our talk is called Eyeing the Onion, I think you'll see that the architecture really can't be divorced from actual the visualizations and what you can do with the product, because they're pretty intimately related, and it's not by accident or filler that we're talking about the architecture. And then I'm going to get into some of the integrating conditional data into ELSA, into Security Onion. And then finally, we've got some dashboards and some new material and things we want to show you guys as we get started. But anyway, Security Onion makes a lot of data. What do we got already? We've got Snort, Suricata, we've got Bro, we've got OSEC, and as we're going to point out that a lot of this we can funnel into ELSA, and you're going to see really the power of what ELSA can do for that data. But you know, it doesn't stop there, because I think SecOps needs a lot more data. You know, what's inherent in Security Onion now is fantastic, but as you move forward, I think that you're going to want to get a lot more data into there. You're going to see the power of correlation. One of the most, I personally think the best feature of ELSA is that map reuse, the ability to look across data sets and see how does everything relate in your network. And we're going to talk a little bit about some of the integration stuff and why that's important. But things, you know, anything that spews syslog is a good candidate for getting into ELSA or looking from a SecOps perspective. Windows logs, also very good option to put in there, how you can do that type of correlation. Firewalls, if any of you run pfSense, I have a small blog post of how to integrate pfSense and parser for ELSA. So very slick, just basically uses the existing firewall access deny and firewall connection end classes built into ELSA. But I think hopefully when we're done with this talk, we will give you, our objective is to give you two things. One is give you an idea of what data is existing inside of Security Onion and what you kind of get out of the box. The second thing is to say, okay, I need to look at my network and figure out what other data might be useful to me, primarily from an IR, but a security, a general overall process, I think is where we're heading with that. So that's our introduction, and I'm going to let Brad, who is the expert in all things Splunk and ELSA, take over now and start talking about it. Okay, sure.
Yeah, I mean, we talk Splunk and ELSA because they both are similar. They index raw log events, they parse fields, they give you Google style searching. Those capabilities are there. There's a few different distinctions where, if Splunk's got some capabilities that ELSA may not. But really, if you flip to the next slide, it boils down to three things. Money, because Splunk costs a lot of it. Speed, ELSA will give you sub-second searches in most cases. And looks, Splunk's prettier, really. That said, we'll show you some things as we go along that we're trying to pretty up ELSA a little bit. For the record, ELSA stands for Enterprise Log Search and Archive, if that wasn't covered in Doug's talk.
That was our trivia question.
Well, now they know the answer, so no, they should not miss.
First person to raise their hand.
Okay, if you could flip to the next. So, why do a Splunk app for SO? Why take something that's free and stick something that costs money on top of it? The main reason and value I think most people will get out of the Splunk app is to learn the data that you're collecting with an SO instance. For home installs, for small office installs, the free version of Splunk will give you 500 meg a day you can index. That's more than adequate for small environments. And as you'll see as we go through, we've got some screenshots, and if we have time at the end, we'll do a demo of just how powerful Splunk can be to really provide you an entry gateway into Security Onion data, and specifically the Bro data, because that's really where the wealth of value is. So what are some of the things you can do with the Splunk app, as well as take from that and carry into ELSA? Learn the logs. Understand what Bro SMTP logs doing, what Bro DNS logs doing, what Bro Con logs doing. Then follow the UID. Bro IDS logs will log, for every event that's logged, a UID gets tagged. And that UID carries through the various log formats. So for example, if you go visit cnn.com via HTTP, you're going to generate a Bro Con log event with a UID. That UID is going to match a Bro HTTP request event in the Bro HTTP log, which is also going to match a DNS event. And so you can, through that UID, you can take a session and see exactly where all of the different Bro logs had detection. Then take the next step, which is understanding how all of these log events relate across the tool sets. Not just how Bro relates to itself, but how you can leverage Snort and Suricata or OSAC. And as Chris is going to demonstrate a little later on, how you can leverage other data and bring other tool sets in to really provide you some great visibility. And the last thing I think that's key is identifying normal from anomalous. Get a sense of what is that normal baseline, and that will make the anomalous really stick out like a sore thumb. Flip. So this is a quick screenshot of the overview dashboard, and I hate pie charts. I really want to just use them as targets to take out of there, but those basically just kind of give you a sense of the data that's being collected. But you can see along the bottom down here, we've got squill events. So basically, we're getting some Snort Suricata data. And what Splunk allows you to do is to really kind of do a search and then compound on that search. So not only do you have what the event is. You have the count of events, then the unique sources in that count, the unique destinations, any geo-IP lookups, and then you can also be grouping by severity and whatnot. So it can really give you a really good sense when an alert is fired exactly how dramatic it may have been and how many sources may have been involved or destinations. Let me flip to the next one. And this is kind of taking this a step further. So this is what we were looking at a moment ago. All of these are clickable, so you can drill down to then start seeing more information. All the Bro events that were, part of that conversation that triggered the alert up above. And then you can also break it out by responder, destination IP, source IP, a lot of different ways. And we'll get into a little bit of that if we have demo time. And then lastly, you can click from that to drill down to the actual raw event data. And one of the more powerful features is the little drop-down arrows over there. There's a bug in Chromium NSO where if you actually click on the white part, it's going to redirect you to the top of the page. But if you click on the gray part, it'll give you a drop-down where you can do things like an incident response search for the source and destination IP. You can do raw text lookups. If you've got CIF integration, and I've got on my blog some details on how to incorporate CIF, which is Collective Intelligence Framework, incorporate some of that data into Splunk, so you can then do lookups against that to see if this is a known bad, if there's any sort of confidence severity ratings and whatnot associated with that from public sources. That capability is also in ELSA, by the way. And those are the links for the Security Onion for Splunk and the Security Onion server sensor add-on, which you can deploy onto Security Onion boxes to have those pull back to a central Splunk server if you've got a sort of a distributed environment. And we'll get to a demo hopefully in a little bit. But that's sort of an overview of how you can leverage that app to learn a little bit more about what's going on with the data you're collecting. Moving on, we need to talk about ELSA architecture a little bit. The ELSA version that is currently in SO is old. It is, as of February, March, Martin was super busy and did some major re-architecturing. Whereas before, ELSA required exposing Sphinx and MySQL ports and using sort of more raw communication, now we've got a full web API integrated in it, where you can actually use SSL to communicate between sensors and to query against log nodes. And so flip to the next slide. This is a sort of prototype, if you will, of where ELSA may fit within the new Security Onion image once this gets incorporated, which, in the next month we're targeting? Should be. Yeah,
I think Scott actually asked me to break Martin's fingers when we were here so we would stop coding so we can get another step version. I think that's something worth raffling off.
Yeah, exactly. So yeah, in a traditional environment where you may have 3 Security Onion sensors reporting into a server, with normal ELSA at the way it's deployed today, all your log events are going to be stored on each of these SO sensors. And then you have the UI on the master, which will then use to query against these nodes for event searches. Well, what the new API architecture gives you is the ability to index logs locally here, or you can forward them on to either your SO master or a standalone ELSA box. Where that becomes beneficial, for example, is when I was last doing an SO deploy, part of our objective was everything we needed to retain or try to keep a hold of, we wanted on the SO server. The sensors, we considered if something went wrong, if we lost drives, okay, we lost 5 days worth of PCAP data. We can recover from that pretty quickly. We've lost that data, but we can at least recover. But part of the concern was how do we retain those ELSA events, that raw event data that we really need for retention, legal requirements, whatnot, as well as for historical searching. And so what this gives you is a little more options in terms of how you want to distribute and deploy your environment, and where you get a little more control over where you want those events to live and be searched against. So these boxes can be either peers or forwarders or both. So we were talking with Martin a little while ago, and he made the suggestion that a really interesting way of architecting this type of deployment is to do your indexing on your sensors and then do archival on the server. So you get faster search responses when you're searching against indexes. That gets you your sensor data. Your server is archival, so you're getting compression and a lot more capability to store vast amounts of data. Your server also, typically isn't going to have the disk costs that you're going to get with a sensor doing full PCAP data. And so it gives you at least an option for managing that data, getting you some retention requirements, getting you a little more control over that. And I know Doug and Scott are still working on kind of thinking through how they're going to incorporate some of this new capability in Splunk, into SH. Seriously. Yeah, you can jump to the next. So that said, let's look into a little bit of what's behind the scenes with ELSA. There are primarily two config files in ELSA that matter. The ELSA_web.conf and ELSA_node.conf. Both are in /etc. And there's really only a few things in there that you need to worry about tweaking if you're going to start customizing. In the ELSA_web.conf, you have basically your peer relationships built. So on a standalone ELSA, you have an API key user and an API key. And that API key can be as long as and as gibberish as you want it to be, obviously the bigger the better. And within that API key, you can define the local host as a peer. So it's, again, in standalone mode, that's the API key and the username to access this local peer. So when you run a query, that's what's used to communicate locally. Taking a step further, you can have a master with a peer. So in this case, you can see we've got a username secops with an API key of 001 on the local host. That's talking to a peer at 192.168.0.10. That's username's IT ops master, and there's an API key. Flip to the next slide. This gives you an idea of what that might look like architecturally. So in this case, you've got an ELSA master that's considered secops that is pointing to an ELSA peer that's collecting Security Onion data. That ELSA secops master also has access to an ELSA master for IT operations. IT operations can't query the secops data, but the other way does work. And then you can have peer data defined within IT ops. And as long as the master being queried has access to peers, it follows it upstream. So you've got that as access control. The ELSA_node.conf, there's three things really there that matter. The first two are archive and log limit. You can define archive limits as a percentage, in this case 33. And that percentage is the percent of the log size limit to devote for archiving. Following that, the log size limit, which you can either define in byte count or be a percentage, basically tells ELSA, this is how much of the disk I want you to use for either index or archive logs. So the third option that you really can look at in the ELSA node is the forwarding configuration. And the way that basically works is you configure an ELSA instance as a forwarder. Any events that come into that box via syslog or other sources get parsed, they get compressed, and then they get forwarded up to a defined ELSA peer that is a storage node, or it may be a forwarder node sending it up to another box. But it gives you a way to collect events. In most cases, it's really applicable when you've got either wide area networks. You may not have the capacity to be sending raw syslog data across the pipe and want to. And the compression really helps you optimize that a bit. And flipping to the next slide, you'll see the different forwarding configuration options that are available. Basically, the method is how or where you want to forward events, and there's several capabilities here. You can see there's SCP, you can do just raw CP. URL is the SSL-based method. And then lastly, there's an option down here called ops. And what that does is allows you to configure a separate ELSA instance, or the same if you want, where you can forward the web.log and node.log, which are ELSA's two primary log formats. You can forward those up to a dedicated ELSA instance. So you've got sort of central management for troubleshooting and investigating your ELSA logs. So under the hood, and before I pass it back to Chris, just to give you an idea of kind of how the flow of data happens with ELSA. The events come in either via syslog or from a forwarder via SSL, zipped up and pre-formatted. Once they hit ELSA, if it's syslog, it goes through a pattern DB, which helps with the parsing and extracting the fields. If it's pre-formatted, it just gets extracted. Those resulting files get dropped as raw text into the ELSA buffers, at which point, if you have archiving and indexing enabled, copies go to both. The data that goes into the index database then gets hit with Sphinx search, which goes through, indexes the data, really allows for fast searching. Sphinx, real briefly, and I'm not sure if Martin's going to talk a little bit more about this or not, but no. Sphinx stores data in temporary indexes and permanent indexes. Temporary indexes are in RAM, permanent indexes are on disk. There's some subtle intricacies when you're searching within ELSA. If you don't really define any search terms, keyword terms, when you run a query, it's typically going to go against the temp index only. So if you go into ELSA and say, search class equals snort, it's only searching temp index. If you say, search TCP class equals snort, that's going to hit your permanent indexes as well as the temp. So it gives you a little bit more of a data set there to go off. Yeah, I think that's all on this. So I'll pass it off to Chris and let him talk a little bit about getting some data in.
As way of to prime that discussion, I want to just have a little bit of differentiation between event and condition type of data here. Event is what's typically sent over syslog. You think of event data, it's the action of basically an asset, something's doing something, right? It's usually associated with the time that occurred. For example, a user logged on at this time, a user logged off, and a virus was found, a packet was blocked, whatever. Something happens at a particular time. And there's usually other stuff describing that. Common stuff, there's source, destination IP, source ports, destination ports. Everything in there that's really, that kind of describes that action in that event. And that's extremely valuable. That is like the thrust of what we're as doing IR, any type of routine work. We want to know what happened. There's this. I wanted to talk briefly about what it means for kind of like a conditional type of data. Really, condition I'm looking at is really the state of the asset. It's not like something that happened, it's what that individual or what that thing was. It was the state of that asset, perhaps we're going to look at the time of the event that particular event happened. And usually, instead of actually as being occurred, it's not like a time that particular event occurred. It's a state at a particular snapshot in time. For example, it was running this firmware version when this event happened. And there's other interesting stuff usually described the state of an asset, such as the configuration data. This is the iOS dump of this, or this was the firewall configuration, or this was the 20 some odd users that were on the box at this time. These were the processes that were running. So a little bit about where I'm going with this. There's so much good work done on getting event data in ELSA. I want to talk a little bit about some of the conditional data or configuration data. So just got a real quick sample workflow. An analyst sees something bad happen in SO. They say, uh-oh, let's dig deeper into that. There's usually two things which they want to see. They want to see other events that happened about that same time. Just get some context, build that context, and other behavior from involved assets around that same time. Now, that's a dramatically simplified view, but that's just kind of simple of what's going on. What I was looking at is I think it might be helpful to know a little bit more about the conditions of the asset at the time that event happened. So can you tell me more about what this box was like when that particular event happened, or what this configuration was when that particular thing happened? And then that's the kind of the thesis here of what I'm looking at and the type of data I want to talk about getting into ELSA. Now, there's all kinds of helpful things that you might know. It might be good to know what processes were running, what ports were open, what services were listening, what OS was on the box, what known software was installed on it, perhaps even any known vulnerabilities that were happening. This is like a Windows workstation or something. So all of those might be useful. It might be useful to be able to pull them up quickly when you're going through this process. So the question I'm attempting to answer here is, where can I find this information, number one? And more importantly, how do I get this data into ELSA for easy correlation? That's what I'm looking for here. Now, so what's already there? We already have products that's basically already integrated. I think there's some question on that in terms of getting it showing up well. But some of the things that we're putting in, I know that Scott's going to put in, is this Bro data. Known software, known certs, known host. So basically, if you don't know, Bro listens and says, I've seen a new piece of software. It tags it as a type, HTTP browser. These are the type of things that it's seeing on a network that it can identify based on network traffic. It may be known SSL certs. These are some powerful things you can do if you know what SSL certs are flying across your network. And this is just one running list of known hosts. And all that data shows up. Now, what also might be interesting is putting vulnerability assessment data in there. Port scanners and that type of thing. So what if we could get Nmap or NICTO or Nessus or OpenVAS in there? What would that add to the picture in terms of doing some type of correlation? Now, what I have done is basically I've created a sample script. It's out on my blog. I think it's actually my GitHub account. So what I'm doing is for those 4 individual VA/port scanners that I had on the previous slide, you're essentially taking this VA, the vulnerability assessment XML data, we're flattening it, and then we're converting it to syslog and sending it to ELSA and puts it in the SQL database. So that's essentially how that's happening. And so the flattening process is actually interesting because, again, putting a state or condition time in there is actually important. And separating it out because, if you look at the average Windows hoster, there might be, thousands of different states of condition. You kind of have to be smart about that. You don't want to put them all on the same log line, but you want to make sure that they're all going down there. But this is essentially the idea behind getting vulnerability assessment data in there. Let's take a look at this. I'm just going to show you, again, forgive me for the quality there, but basically the script's pretty simple. Python v8elsa.py, you give it the place of the report, report.nessus, the report type, you let it know, and you give it the ELSA IP address. I mean, that's basically it. Actually, I haven't shown this on the script slide here, but I actually have flags in the Python script, so I think if you would do a -x, it will create the XML for you and just pick it out to an output file. You can just copy it into your patterns DB or your merged XML. If you do a -s, it will actually create the SQL, so you can do a MySQL dump right into it. So doing this way, the schema will already be updated. For bridging that gap between when this schema is already built into SO and now, you can use that as an opportunity for there. But this is just a sample of that. I've just done a CVE here. This is some of the Nessus class. You've got, basically the source IP, destination IP. You've got some of the service, the risk factor, that type of thing. And this really goes above and beyond traditionally what you're using vulnerability assessment data. I used to do pen testing and vulnerability assessments, and the name of the game was like produce pretty charts, right? You gotta have pie charts, you gotta have the table charts, you gotta have how many high risk, low risk, and all that kind of garbage. And in process management, it's 300 pages that goes in the drawer, and traditionally the sysadmin is too overworked to actually do anything with it, right? But anyway, same type of concept here. Python, you basically put an XML report in there. This one I've just listed there. and then you give it an ELSA IP, and then that's basically what it is. And so you get a little bit of a description. And OID, I've tried to put the NID or the OID from any one of these tools, the OSV DVID from NICTO, if that's available, so you can do some cross-correlation. Just pretty simple, Python limited there. Now let's just actually put this all together. This is a sample search I've done up here. Suppose you just want to do a blank search, class equals nessus, risk factor equals critical. Just quick show me the last scan I did, all the critical vulnerabilities on my network. Maybe that's helpful to you. And I think that's partially helpful, but I don't think that's extraordinarily helpful. Might give you a picture about what's living on your network. Taking it a step further, here's what I've done with this particular ELSA query. So I've actually used the sub-search transform here in ELSA. And this is what essentially I'm saying. Show me all IP addresses that requested a resource with PASSWD in it. So it's, this might be some directory traversal type of thing, where the server they communicated with had a vulnerability rated as high, and the type of that vulnerability was web application abuses. Okay, so that's actually what we're looking at here. Class OpenPAS, host type, right? Risk factor high, group by destination IP. Pipe that to sub-search. Look for Bro HTTP. The URI basically contains PASSWD in it, and then group by the source IPs. That will get you that type of list. And you can imagine kind of similar type of thing. NICTO, if you're doing web application scanning, right? And if NICTO will actually let say, here's the directory that you might have an issue with, right? This is where we found an insecure Apache directory. You could look for that, you could pipe that in there, and then you could look at the traffic if Bro HTTP is examining it and see if there's any actually request for that particular resource. So this is some of the things. I'm going to take it one more step here. Let's take a look at this. This is tell me all of the sites visited that had a country code captured from who is not in the US and where the client had a user agent string containing Java and a critically rated Java vulnerability as discovered by Nessus. Okay? Again, start with Nessus, look for Java, risk factor critical, group by source IP, sub-search, pipe that into a sub-search, looks at Bro HTTP, user agent is Java, so it contains Java in it, so it's a vulnerable Java version, group by destination IP, and then I'm bringing the source IP from the previous search into that. So that's what I'm thinking, and pipe that to who is, and then pipe that, filter all that who is data, take out the US from the country code. Okay, that's just some like ELSA. It gives you an idea of what you can do with conditional data. I think why that might be important in actually doing your analysis. So, one last thing here I want to talk a little bit about. I actually have another script maybe where process data is important. Again, snapshots processes are running at a particular time. What does it look like? I just basically have a simple WMI script. Again, I know there's some inherent vulnerabilities and limitations with WMI. I might look into doing some other ways of collecting that process information. But all I'm doing is saying, I'm going to take WMI data, convert it to syslog, and send it to ELSA. And let's see if that's valuable. Here's some of the information I'm collecting on it. For example, the operating system, the process ID, the parent process ID, the name, the creation time of the process, and then the source IP where I got it from. All right? And then finally, again, I'm going to just go through here, is currently executing Java processes on a box, right? Depending on how often you run the script. Actually, I got something is amiss here. This is kind of interesting. If you look like, I just did a search for cmd.exe, C Windows System 32, cmd.exe, C Windows System 32, cmd.exe, and then finally C Documents and Settings, Desktop, cmd.exe. So it's kind of, like just something jumps out at you like that from the directory. I should have done this, but if you do a group by executable pet, this stuff like jumps out at you. You know what I mean? I mean, it's this is odd. It's not running there. Again, what I've learned from building lots of parsers, number one is familiarize yourself with existing classes in ELSA. Use syslog, select star from classes, select star from fields. Understand what the schema is and what options you have. I think just from understanding the schema, Martin's famous saying, this is ELSA was built for IR by IR, and he specifically designed what fields and schema for that process. Definitely reuse instead of building new. I've made many mistakes where I've just built new fields and I shouldn't have. And then think about the IR process. How can I link this log type to other log types? That's the big thing. How can I pivot on that data? If it's a source IP in VA, if it's a source IP somewhere else, how can I pivot and get back and forth? When you're writing parsers, as we're going to learn this afternoon, how can I do that? And then what would be important for me to filter on? Map reuse in ELSA, my absolute favorite function. How can you take that and filter from it? Again, some of the new content, I'm not going to take credit for all these because Scott has done some of these, but I think we've rounded out all of the Bro parsing. I think that's all of the Bro logs, so I think we're in good shape there. And it'll eventually get integrated. And then, again, this is the VA integration. I'm going to jump out here. If you guys have any questions on this, my contact information is conveniently located at the bottom of the slide. Please let me know if there's issues. There's a lot more I can do with that, but this is kind of just my first pass. And then some of the dashboards, we're running up at the end of time, so Brad, I'm going to let you just kind of talk through some of the dashboards because he's done a fantastic job with these.
Yeah, I mean, so ELSA uses Google visualization for dashboarding, and it's pretty much as simple as running a query saying, hey, those results look useful, add to dashboard, and you can drop them into a dashboard. And so we're working on trying to replicate some of what I've done with the Splunk app for Security Onion and pull that into ELSA to give some of the similar value. One limitation right now is there is no click-through capability, so there's not the ability today to drill down on these events. But thankfully, a ELSA contributor recently submitted a patch that Martin is hoping to get incorporated here in the next few weeks that's really going to help with that click-through capability and make these dynamic. Make these a place where you can launch further actions from versus just sort of, okay, I need to take that and go back into ELSA and do some searches. And in this case, you just got, you know, some suricata alerts by classification and then by message. This gives you an idea of all the Bro sources that have come into the network. And then this very handy little slider bar, so you can really slide it out, zero in on a specific time frame, and get a sense of what type of activity is occurring where. This is an overview dashboard, which basically checks Bro's connection log and gives you a display geographically of where you've got connectivity going. Again, it's an overview. This is a sense of what's going on in my network. This is a breakdown of the events by class. Again, these are not necessarily archive searches, so these results aren't going to be for every bit of data that you've ever collected with ELSA, but it will be data that you've collected that's indexed and capable of Sphinx high-speed searching. So in most cases, it's going to give you a really good sense of relative activity over a period of time. And that period of time may vary depending on how quickly your index is rotating. And then, you know, notices by type for the Bro notice field. And then some more Bro breakdown, which Snort's usually way more chatty than Bro. This is a dashboard we've started on that's for net hunting. And the idea here is to try to break down some data. So, you know, in this case, you've got class equals Bro DNS group by host name. Okay, well, that's a lot of data. Well, you can click on the header to reverse your sorting, and you can start looking at the infrequent domains that have been hit. And usually you can find some gold mines when you're digging in there. And then things like user agent that have been detected, HTTP-wise or SMTP.
I just like to point out this is from my home network, so I'm like one of the 7 people that actually owns an Apple TV. So I'm guilty as charged there, but I do like it though. Sorry.
Yeah, and this is one I released actually a few months back on my blog. It's a web monitor. It was kind of designed to give me, a parent, a sense of what kind of activity is going on in my home network. So it doesn't really have any direct security practices, I don't think, but it's that, again, that sense of visibility and awareness that, you know, oh look, HTTP traffic to China, to Russia, to Ukraine. Okay, I've got some things I need to look at, obviously. Is that the last one, I think?
Yeah, one more I wrote my time, so I'm
Yeah. Yeah, and again, just some of this, a sense of the different types of data that you're getting from Bro. You know, Bro IRC data, SMTP data, so you can tell what types of mine types you've been seeing coming across in your SMTP traffic, known services, and this is useful for baselining your network, for knowing the normal. I identifying normal and making those anomalies stick out. And then lastly on this one, the Bro weird. One of the key things to point out though is this, I can't emphasize enough the speed disparity between Splunk and ELSA. I mean, if you've looked at the Splunk app, it does some pretty amazing things with the queries, but if you do that on a large subset of data, it's going to take a long time. I mean, the tool is really built to learn from. It's not necessarily built to be a production solution. You can take it and tweak it, and it can become a production, and we did run it as a production solution. But these, I think the net dashboard, we've got almost 20 queries, ELSA queries built into that single dashboard. And that single dashboard will load up quicker than one sub-search that you saw earlier in Splunk, where you're having to do a lot of different transforms to manipulate that data. So it's very, very powerful in terms of the speed and performance.
I think we're up on time.
Yep.
Maybe time to take one or two questions if you have it. Yes, sir.
Just, what's the largest deployment of this you've seen?
I'll let Brad handle that.
What were we, was it 50 billion? Yeah, 50 billion events.
Global. What's a global?
Are you talking about ELSA or are you talking about SO?
SO.
Okay, that's a different, like how many sensors?
Oh, yeah, lots. David, SO sensors, have you heard of
Oh, I don't know.
hundreds? I mean, I've heard of hundreds. You know, in my previous organization, we were a company of about 10,000 people. We had 3 egress points where we deployed Security Onion sensors and then had a Security Onion server. And the longer term goal before I left was to use those sensors as a collection points and ultimately have them feeding ELSA data back to that Security Onion server. Because we'd spec'd out hardware that was comparable for all 4 boxes. And you know, Security Onion server isn't as disk intensive as the sensors are. The sensors have got that PCAP data, you know, and right now they're storing the ELSA data, so there's a lot of data being stored on those sensor boxes. And that was the longer term goal, was to try to keep that PCAP data on the edge, but try to bring some of that ELSA data back towards the center where we could have a little more control over retention and things like that.
Did you guys do your giveaway?
No, Chris, you had to put the
Okay.
trivia.
Here's the trivia. It's kind of coming from our presentation here. What are the 2 fundamental configuration files in ELSA?
Martin can't answer.
This gentleman right here in the blue shirt.
Is it ELSA_web.conf and ELSA_node.conf?
Yes.
Congratulations.
Good job. Excellent.
We got a new book on there.
Richard has signed this. Here we go. Congratulations. Okay.
And we'll be around. I mean, if we didn't really have time to demo any of this, but you know, if anybody wants to see a little bit of what we've done with both the Splunk app as well as the dashboards that are going to be coming to Security Onion before too long, we'd be happy to show those off.
That's it. Thank you, everybody.
Thank you.
Great job, guys.